Okay, we can continue with the discussion. So our next technique, classification technique, which is nothing but an extension of our decision tree technique, is called random forest, right? So before I am going to discuss about the random forest, I would like to discuss about the various kind of measurement that we generally use for classification purpose. Very important. Okay, how we can evaluate our model, or how we can do the evaluation and selection, that which one is the best model, or you can say the accuracy of the model. Okay, so model evaluation we can do with the help of metrics. How can we measure the accuracy and other metrics to consider? It is very important part that each and every classification model should have gone through this part, or should have gone through some kind of model evaluation and selection. Okay, to check out the quality of the classification model that you are using, or you can say the accuracy of the classification model that you are using. To check that one, we are going through this evaluation metrics. So use validation test set of class level tuples instead of training set when accessing accuracy. Obviously, when we will access the accuracy, I am telling you that I have already told we can access the accuracy in two ways. The first way, we can access the accuracy during the training phase when we are train our model, and also we have to access the accuracy during the testing phase when we will check how our model will perform in an unseen, or for the case of unseen data or unlabeled data. Can our model will give the perfect level to that unseen data, or a correct level to the unseen data or not? That is actually represents the accuracy of our model. So in case of evaluation, we will majorly concentrate on validation test data set instead of a training data set. Okay, training data set is only for the accuracy of the training method. Okay, but major accuracy we will need to find during the testing phase or evaluation test data sets, right? For unseen data. Now, these are the various methods for estimating classifiers accuracy: holdout method, random subsampling, cross validation, and bootstrap. All of you have some idea about the cross validation, I know it. And bootstrap is there. Bootstrap is nothing but an ensemble technique and comparing classifiers, confidence intervals, and ROC curve. Okay. Majorly, we have to first calculate the confusion matrix, which is the first and foremost important part, by the help of which we are able to calculate or evaluate the performance of a model at the testing phase or during the validation phase. Okay, this is the confusion matrix will look like. If you look at this screen very carefully, this is the confusion matrix look like. This is the confusion matrix generally consists of a, it is a 2 cross 2 matrix for a binary classification problem. We will introduce the confusion matrix of 2 cross 2. That means total 4 cells are there. Okay, for binary classification. For ternary classification, it means when there are more than two variables, two class levels, or three class levels are there, then we will consider 3 cross 3 confusion matrix. Okay, but majorly for your curriculum, you are going to focus on binary classification kind of problem. I already told that. So according to the y-axis, it will represent the actual class. Understood? According to the y-axis, it will represent the actual class, or you can say actual data. And according to the x-axis, it will represent the predicted class or predicted data. So what I have told, according to x-axis, it represents the predicted data or predicted class, and according to y-axis, it represents the actual data or actual class. Okay, try to understand what I'm trying to say. So So the confusion matrix consists of these 4 points or 4 observations. One is true positive, one is false negative, this one is false positive, and this one is true negative. Okay, true positive, false negative, false positive, true negative. TP, FN, FP, TN, short forms or abbreviated forms. So true positive means when the actual class data is yes and your predicted class data is also yes, then it's called true positive. What I'm saying that when your model will give a prediction yes, and your actual test data from which you are trying to compare that whether your model has given a correct prediction or not, it will also give yes. That means yes and yes, both are yes. Then it is called true positive. Okay, true positive. Now, next case, in this case, false negative. False negative means your model have predicted yes, but your model has predicted suppose no, but your actual class or actual data represents yes. So it's totally mismatched. Your model predicted no, and your actual data gives the class level yes. So it is called false negative. False positive. False positive means your actual data represents no, okay, and your predicted class will give yes. So this positive, this second term, positive negative, are represent the predicted class, and the first term, true and false, are represent the actual class. Remember it. The second terms, positive negatives, are represented the execution or output of the predicted class, and this first term, true and false, are represent the output of the actual class or actual data. Okay, and in the last case, when both are negative, when your model predicted is also negative as a class level, and your actual data is also negative, so both are negative, then it is called true negative. So one example has been given. Suppose a computer electronics showroom is there, who actually selling computers. Okay, so buy computers is a parameter, or you can say it's attributes, which not attribute, so it's a class. Okay, a class attribute, you can say it's a target class attribute which has two values, either yes or no. It's a binary classification problem I already told. So if buy computer at actual class is yes, and your predicted model will also give a prediction of a buy computer is yes, then it is called a true positive. And suppose the number of true positive is 6954. Suppose total number of data is 7,000. Okay, so total number of tuples in the data set is 7,000. Okay, we will assume it. And among this 7,000 data, suppose 6,954 will represent true positive. That means your model gives a good one. And in this case, false negative will represent 46 data, or 46 tuples are represents false negative. That means your model predicts no, but the actual data predicts yes. Now, in buy computer, total 10,000 data are there. In this 3,000, this false positives will represent in this class. So 412 data are represents false positives, where your model, your actual data says no, but your predicted model predict yes. And this true negative, that means both are says no. Your model also says no, and your model, your predicted also says no. So in this case, can anyone tell me which two column will create a major impact for calculating the accuracy of a model? According to you, what do you think? In these four columns or four cells, which two cells will create a major impact of calculating the accuracy of a model? মানে কোথা থেকে আমি বুঝতে পারছি যে model accuracy is a good one? From which cells? What do you understand from this confusion matrix? Anyone can tell me? Any one of you? What do you understand from here? Hello? Any one of you can give me the response and tell me from which cells.
No idea.
Sir,
Yes, yes.
sir, can't understand the question, sir.
I'm asking you. These numbers has been given to you. You have already understood what are the job of these numbers. What these numbers are represented, right? Now the thing is that I'm asking
Yes, sir.
to you, from these numbers, what do you think that which cells give a major impact to the accuracy of a model, to calculate the accuracy of a model? Which cells among these four cells means give a positive view that a model is a good accuracy? Give a positive view.
Sir,
Sir,
yes is more than no.
Sir,
Yes.
accuracy will be based on actual class or predicted class?
Accuracy is based on
By yes, sir.
yes. So this
Yes,
cell,
row, sir. Yes.
this
Yes,
cells,
one.
true positives and these true negatives.
Yes, sir.
These two cells are
Yes, sir.
responsible to boost up the accuracy. I am trying to say accuracy is based on, accuracy is nothing but that how much you have achieved divided by total number of appearance. That means total number of appearance means it may be a combination of your achievements plus non-achievements. Okay, that is the accuracy calculation. Okay, so in accuracy calculation, both achievements and non-achievement has a similar kind of impact. But I want to say which will increase, which two cells are giving an improvement or increasing, or we can say that this model is getting towards the good accuracy. And these two cells will represent that thing. One is true positive cell, another one is true negative cells. So this entire matrix is called a confusion matrix, and this play a very, very major role or vital role in any kind of machine learning or data mining algorithm. Okay, to calculate the quality of the model or quality of your algorithm, or to measure the matrix. Okay, so to measure the quality of the model. Now from here, we are going to calculate some parameters. The first and foremost parameter that we are going to calculate is accuracy. How we can calculate the accuracy? Porikkar hall in the examination, they may give a table to you with some values, and they can ask you to calculate the parameters. Okay, so you have to understood the confusion matrix, and based on the confusion matrix, you have to remember this formula. Not remember, you can just understood it. So you can understand that TP plus TN. Look, accuracy, how we can calculate TP plus TN. That's why I'm saying these two cells will give a major impact that the model may have some good accuracy. So this is TP, this is TN. So from the accuracy calculation, the numerator part will consist of these two cells, TP plus TN, divided by all. All means all the four cells. Summation of all the four cells. That means TP plus FN plus FP plus TN. Okay, that is the way of how we can calculate the accuracy or classified accuracy. And error rate is just opposite of accuracy. 1 minus accuracy is nothing, is equivalent to the error rate. So error rate generally consists of these two columns. These two, the opposite two diagonal columns. Okay, if you calculate the error rate, these two will be the numerator. These two, summation of these two columns, false positive and false negative, will be your numerator. Is 1 minus accuracy, right? Now sometimes you have faced a problem of class imbalance. What is class imbalance problem? Class imbalance problem is such kind of problem. Suppose there are total 1,000 instances in your training data sets. Within these 1,000 instances, suppose 90 instances are yes and only 10 instances are no. So we actually trying to say the model will perform very well, or model will perform good for such kind of training data sets where the yes or no, that means the class levels are generally following the equal kind of ratios. That means 1:1 or 1:2 or maximum 2:1, not more than that. But here, if I will give you the example of this 1,000 tuples where 900 tuples represent yes and only 100 tuple will represent no. That means the ratio is very poor compared to yes and no. And this is called a class imbalance problem. Okay, the classifiers will not give you a good results. So please remember about the class. What is class imbalance problem? You can identify and you can tell the answer of this class imbalance problem. Okay, I think you have understood that thing. Apart from accuracy, there are 4 parameters which are also required to calculate the classifier quality, or you can say the classifier evaluate metrics. The first one is precision. Precision means what percentage of tuples that the classifier labeled as positive are accurately positive. That is called precision. কতগুলো তোমার model label করেছে as a positive and কতগুলো actually positive, that will be defined. So that's why precision will made up this ratio with only positive cells. That means true positive divided by true positive plus false positive. Okay, true positive divided by true positive plus false positive. Second parameter is recall, which actually represents completeness. That means what percent of positive tuples did the classifier label as positive. So true positive divided by true positive plus false negative is a calculation of the recall. Okay, so if the recall is 1, if the calculation, the output of the ratio is 1, then it's a perfect score, perfect recall. Okay, inverse relationship between precision and recall. So these two are inversely proportional with each other, precision and recall, the relationship between them. Now we'll calculate the third parameter, that is F measure or F score, which will nothing but a measurement with the help of precision and recall by the help of ratio of 2 into precision into recall divided by precision plus recall. That is the calculation for a F score. That is the formulation for a F score. Okay, you don't require to remember this one. We generally not using this F beta measurement. Okay, it is nowadays now we are not using this kind of measurement. You just remember these 3 measurement: precision, recall, F score, and the final measurement is accuracy. Okay, and if you measure the accuracy, error rate is just opposite of the accuracy, you know that. Okay, so these are all your accuracy. So on this current given data sets, whether the patient has a cancer or no, yes or no, this is the corresponding calculation of the accuracy 96.40. This is the corresponding calculation of the precision. This is the corresponding calculation of the recall. Okay, apart from this, there are some other parameters like sensitivity and specificity is also there. So in this slide, there is a sensitivity is true positive divided by total number of positive and true negative divided by total number of negative. Actually, sensitivity and specificity we generally not calculate. We generally focus on the calculation of these 4 measurement or 4 parameters: precision, recall, F-score, and accuracy. Okay, these are the 4 measurement that you see in most of the research papers. You will see that these are the 4 measurements that the classifiers are generally follows to measure. Okay, is it clear? Anyone has any doubt up to this in this measurement? Anyone has any doubt? Is it clear about confusion matrix and measurement?
Yes, sir.
If this kind of table will be given in your exam, I think you are able to calculate the values. Okay. Okay. So let's go back to the discussion of random forest. Okay, random forest is a
So-
very small one. Yes, please. Any question?
Sir, can we stop there? Sir, can we stop there, sir? Actually, it's very much hectic.
Overloaded হয়ে যাচ্ছে?
Yes, sir.
Okay, random forest খুব বড় ছিল না, it's a very small one, and the support vector machine we can start from the next class. Okay, if we finish the random forest, it's not a bigger
क्लास में
one.
कर लेंगे ना सर, नेक्स्ट क्लास में कर लेंगे ना।
Sir, SVM we have studied in, sir,